So one other thing that I would like to look in this video that I didn't get a chance to look at least in my previous one is can I somehow look at my IO class in Haskell and can I make my IO class an instance of the functors type class? So so let's say I've got my IO class defined in Haskell, and I'm just going to directly start at this point uh, to have my IO class an instance of the functor. So I could start off with something like this. I could say instance functor, and because I'm playing with my IO class here, IO class is the next piece. I was acting as my as a kind that takes in that goes from a star to a star. Okay, and this definition would be where my f map basically takes in a function f. It takes in a function f, and it takes in some kind of a functor value. It takes in some kind of a functor value. So let's call this maybe a functor value x. Okay, and this entire thing is going to be equal to. Now this is a little bit funny over here, but in funny sense because we haven't yet looked at monads here, and we haven't even looked at this idea of what a bind function is, or what a return, or what a return method is. But because I know that IO is basically a monad, and Haskell, I'm just going to at least to complete this method over here for my fmap. I'm going to assume that or at least I'm going to give the signatures. I'm just going to give a signature for my a bind and for my return. So a return is basically a method. Is a method that takes in one value as a input and gives you back as an output m of a, where m is some kind of a monadia, and I then have a bind operator. I have a bind operator which basically is defined with these signs over here, the less than, equal to, which works in the sense that it takes in a monadic value, which is something like m of a, and it takes in a function. Which goes from a to let's say m of b, and out comes back a value which is m of b. Okay, so assuming that I have these methods implemented for the IO, where IO is basically a monad, right? So M in that case becomes an IO, right? So this is the generic behavior defined in the class monad, but I'm going to assume that IO is basically a monad. So instead of writing M of A, I'm going to write this as IO of A. Okay, so this is IO of A. I'm going to get this M written as IO of A, and this M over here as IO of B, and this M as also as IO of B. Okay, so given these methods over here, how does fmap of f of x look like? So fmap of f of x for the type IO is going to look like, if I complete this off, it's going to look like fmap takes in function, it goes from A to B, and this is going to be IO of A to IO of B there. Alright, so this entire thing is going to be equal to, let's look at this value x here. This value x over here is basically this piece over here, IO of A, which means over here, this is that piece over here, right? So I can say fmap of f of x equals to, I'll take this monadic, or in this case this value x, and say I'll take that value x, whatever that x is, and I'm going to use my bind operator. Okay, I'm going to use my bind operator there, and I'm then going to this bind operator takes in that monadic value, or in this case io of a, which is x, and then it needs this method. It needs this method that basically goes from A to IO of B. But I do not have any such method. The method that I have here, F, actually goes from A to B. It doesn't go from A to IO of B. But what I can do is I can say, okay, let's have a second parameter. Let's have a second parameter that in this case is a function. This entire thing is a function. So I'm going to pass in that function, which is in this case anonymous function. Okay, so I don't know, this anonymous function that takes in that value A, and it returns back IO of B. But now I have this function, so I can say this function f is going to be applied on this value A, which is going to give you back something of type B. Okay, this going to so this entire thing, the entire type of f of A in this case happens to be of type B there. Okay, but now if I call return on this, if I call return on this entire thing, if I call return, now I'm just running out of space here, so let me just do this a little bit again. So if I say this entire thing is basically return of f of A, right? F of A, when applied, gives me something of type B, and return on that B is going to give me IO of B. So this entire thing, this entire piece over here, is basically a function now that takes in something of a kind A, right, and gives you back something of type IO of B. All right. So this could be this is basically an implementation where IO is an instance of my of my functors type class, and let's just try this. I feel is really interesting because the way I've put it, the way I've put this together, there's some really neat little things that can actually you can do with this fmap. So let me give you one example. Let's do this. Let's actually have an example where I'm going to call where I want to take an input from the user. Okay, so I'm going to call getLine. Okay, what's the type of getLine? The type of getLine is basically an IO of string. Okay, or in some other words, it can also be considered as a function that doesn't take in anything as an input, but gives you back something that's a type of IO of string. So this is a function that will accept some input from the user. Okay, now what I really want to do is whatever is entered by the user, I would like that thing to actually be reversed. Meaning, if the user were to enter a string, which is a pass, it should get reversed to SABBA. Okay, but how would I do that? I have a method called reverse already in Haskell. The method reverse in Haskell, right? The type of this method is basically it basically takes in a string or a list of character as an input and gives it back as an output a list of character. Okay, or if I were to use type synonym, in this case it takes in a string and gives you back as an output a string. It doesn't take in an I of string, actually takes in, it works just on a string here. Now because this works on a string, how am I going to actually make it work by taking in an input from the user? So so to do this, let's use our method fmap. So I'm going to say fmap. Okay, I'm going to pass in my method that goes from A to B, which is this piece over here. Okay, this is my method reverse, and now I'm going to pass in some kind of a functor value, and the way I'm going to pass in this functor value is I'm just going to say getLine, because the type of getLine is nothing but IO of string, and reverse is basically a method that goes from string to string, and when I call getLine, in other words, you can think of fmap as basically a method that is actually going to lift my method reverse that originally works in this space of string to string. So there, now it can actually work in the space that from IO string to IO of string. So let's just try this out. Let's just actually try this out and see how this plays out in Haskell. So so let's do this. Let me just quickly quit this. Let's just start Haskell, and I'm going to say fmap of reverse, and pass in a string. Let's say a pass. Oh, actually, we need this. We need this from the user. So let's call this getLine, and let this entire thing be. Let's say let x equals to this entire thing. All right. So now if I say what's the type on x, well, the type on x is basically an IO of char, or basically an IO of string. So x is basically just a method that doesn't take in anything as an input, but is going to do some computation, which basically in this case is some IO computation, which is going to ask the user for an input, and is now going to give back as an output after performing that IO some kind of a string, right? So if I run this x over here, it's going to wait to take an input from the user. Let's pass in a string, a pass, and out comes back the reverse of that string. So again, this I think is really neat, because all I've done at this point is to take this method reverse, which originally works just in the domain of string to string, and actually lift it so that it can actually work also now in this domain, or in the space over here from IO of string to IO of string. Okay, so I hope you found this a little bit useful by taking a few of our types and making them instances of our functors type class.